Hi and welcome. Today I just want to share a little more about these Maxwell relations and how to derive them. First, you should already know that du, internal energy, equals to Tds minus Pdv. This is actually derived from our first law of thermodynamics. And similarly for dH, it's Tds plus Vdp. dA, which is Helmholtz free energy, equals minus S dt minus P dV, and dG, which is Gibbs free energy, is minus S dt plus V dP. You don't really have to memorize all these equations except maybe the first two. You can actually derive the last two from the definitions of Helmholtz and Gibbs free energy, which are as follows: A equals to U minus Ts, and G equals to H minus Ts. Now let's just move on. We want to know certain properties about partial differentials. Let's say you have del y, del x holding z constant, and you want to differentiate it with respect to z holding x constant. Let's just differentiate this. And this is actually just equals to del 2y del z, del x, z and x. Now let's say you have the differential del y, del z holding x constant, and you want to differentiate this with respect to x. Holding z constant, and you get something like del 2y, del x, del z holding x and z constant. Now holding both constants, so these are exactly just the same. Now calculus would have it that del 2y, del z, del x is equal to del 2y, del x, del z. It doesn't matter which variable you want to start with, but the end result is just the same. So that's one of the first things you need to know before deriving the Maxwell relations. Now you want to apply this to the four equations we saw earlier. Now let's just label this 1, 2, 3, and 4. And now we want to decompose these into their derivatives. So we have internal energy in terms of entropy and volume. So del U, del S, V, holding V constant, is equals to del U, del V, S, dV. Let's call this equation 5. And you want to compare equation 5 to equation 1. Alright, what you can see is T equals to del U, del S, V, and negative P equals to del U, del V, S. Now if we were to apply the partial differential rules, we can actually see that del 2u del s del v, holding v and s constant, equals to del 2u del v del s, holding s and v constant. Now we compare the relations here to here, and what do we get? Del t del v s equals to negative del p del s, holding v constant. Now what do you notice? At the end of all this, you can see that t, you differentiate with respect to v, keeping s constant, and negative p here, you differentiate with respect to s, holding v constant. So that's the net result of what we have just done. This is one of the first Maxwell relations for thermodynamics. Now we want to do the same thing with H. I'm just going to make it a little faster. dH equals to TdS plus VdP. So you can see T, which we just repeat the same steps as we did earlier. Del T, del P, keeping S constant, equals to del V, del S, holding P constant. This is our second thermodynamic relation, Maxwell relation. Now how do we get this? The same idea that del and del P del H del S P, holding S constant, equals to del by, sorry, it's just equal, it's not a definition, del by del S del H del P S, keeping pressure constant. Okay, let's move on to our third relation. They have Helmholtz free energy. Now how do we derive this? dA equals minus S dt minus P dV. Now we notice both of these properties here are negative signs, so we can actually just put this into our equation as follows. Del S del V, holding temperature constant, equals to negative del P del T, holding V constant. Del P del T whole V constant. We just remove both of the negative signs and we will get our third thermodynamic relation. And lastly, we have Gibbs free energy. And what do we do with S? We have a negative del S del P T equals to del V del T P constant. Del V del T keep P constant, and negative del S del P keep t constant. Both are the same. At the end of the day, you will have 4 relations. Del T del V S equals to negative del P del S V del T del P S equals del V del S P del S del V T equals to del P del T V. And lastly, we have negative del S del P T equals to del V del T P. These are our Maxwell relations that we just derived. We don't have to memorize them. As long as we know these 4 relations and all these process, the partial differential rules, we can actually just derive these 4 Maxwell relations. Thank you for watching. Please subscribe, rate and comment.